This video is about ultralight locks and OTP. The lock bytes are also called as a static locks in case of this ultralight tags, and they are called static locks because the position of these lock bytes are always fixed. It is at page number 2. So there is also locks that are called as a dynamic locks. So you find these dynamic locks in memories with higher capacity. It's called dynamic because the position of the log bytes depends on the memory capacity. The main purpose of these log bytes are to protect the write operation. So in other words, if a page is locked, so no further write operation is possible. In the other MIFARE tags, it's also possible to protect both read as well as write. So each page is controlled by a bit in the log bytes. So basically when we speak about the log bytes, will be every bit is very important for us. Every bit controls a page. So if the page is 1, the bit is 1, it locks the corresponding page. But in the higher memories or in the other NFC tags, you can also see a single bit controlling either 2 pages or 3 pages. It's also possible to prevent the lock bits from the write operation. So these are called as the block locking bits. It's basically you're blocking the lock bits. So this is basically to prevent users from locking any page. So some of the applications of this lock bytes are: assume that we have a card and we have written the cardholder name. So all the pages which carries this information can be locked so that nobody can change it. It's also possible that we store the security number in the card and we don't want users to modify. Or sometimes we can also store the authentication key. And one thing you have to keep in mind here is these lock bytes are irreversible. So it means once you lock a page, you cannot unlock it. So we are going to see how this locking is done. I'm going to use a tag now. So this is the documentation from MIFARE Ultralight. So as you can see here, the log bytes are present in page number 2, and these are the 2 bytes reserved for the log bytes. They are called log byte 0 and log byte 1. So the log byte 0, these are the 8 bits of log byte 0, and this bit controls the page 7, this page 6, page 5, page 4, and this bit OTP. And these 3 bits are called the block locking bits. I'll come back to that later. And the log byte 1, these 8 bits they all control a single pages from page number 8 to page number 15. So in case of MIFARE Ultralight, each log bit controls a single page. So I'm going to connect this CR95HF, and I'm going to show you. We're just going to play with this with a brand new tag. So you already seen this software in my previous videos. So this is a brand new ultralight. Connect. I'm going to choose the tag and activate and read. So here, this is the page number, the 2 here, the last 2 bytes, that's the B2 and B3. For a blank card, the log bytes have the value zeros. So I have just shown these log bytes in a nice looking checkboxes here. So you can see here no pages are locked, and in order to lock it, so you first have to fill in the data and then you have to lock. So I'm going to write a few text. So we have seen this problem in the previous videos. So just say that card holder name goes here. I'm going to write this from page number 4 onwards. So 4, I'm going to transfer it here, and we're going to transfer this page number 4 to page number 10 and write it to the memory. Okay, so now I know that this tag has got some data and I would like to lock it. So locking, you would first identify all the page numbers you're going to lock. I want to lock from page number 4 to page number 10. So go to the locking section. So I'm going to page 4, 5, 6, 7, 8, 9 and 10. So I'm going to lock. So basically locking is nothing but writing data for this page. So yes, I'm going to write, and so as you can see here, if you want to read, so I've also made a small change to this software. So I have provided a link here called a read that reads a single page. Now, otherwise the only way to read the data from the tag is to hit this read tag button, which reads the entire thing. So I'm going to show you why this is introduce this read tag here. So read, so I've read, that's fine. Now I also mentioned that these log bits are reversible or irreversible, sorry. So that means you cannot undo it. So in other words, I cannot take out the locks on page number 4 to page number 10. So let us try to do it and see whether you can really is it really irreversible, or just try to prove it, that's all. So here, because this software did not allow you to untick, I've also introduced a tiny icon here. So I'm calling this as a safe and unsafe mode. So if you hit there, it unlocks. So I'm letting you, or the software lets you to unlock or do whatever you want. So you can lock or unlock. I'm trying to remove all the locks, and let us try to write. Let's try to clear here. So I'm going to write it. So the card says the write is successful. If you look at this output, so we got that it's a 0A, it's a acknowledgement sign. The write is successful. But let's try to read this again, okay, from the card. So hit this R. So as soon as you hit this, what I'm doing is I'm just reading the content of page 2 and decoding those values and populating these checkboxes, as you can see here. So even though we try to write, or even basically locking is nothing but changing the byte from 0 to 1, and we try to change the bit from 0 to 1. We try to change the bit from 1 to 0, but however we just saw that it's not possible. So that shows the lock bits are not irreversible. So once it is locked, it's locked forever. Okay, there is something else you have to keep in mind. See, back in the documentation, if you read this this statement here, it says to activate the new locking configuration after a write to the lock bit area, the REQA or whooper command must be carried out. So this also means this locking will be effective in the next session. So for example, I'm going to now take the card out and put it back again, so that everything starts from the REQA. So here I'm going to reactivate the tag and read again. So we are back here. The next thing is about the block locking. So it's easy to understand this if you slow down the first word. So you can read this as it's basically about blocking the lock bits. So what it means here is, so see, as of now, if I give this tag to my customer, so anybody can get a software and play with the lock, and you can lock all these unlocked pages. We know that the lock bits cannot be undone. So what if I do not want my customer to lock any of these pages. Okay, so basically we are preventing the customer or a user from setting these bits to 1. So that is controlled by the BL. If you come across this letter BL, it means it's a block locking, and it also means that you are trying to prevent users from making any further changes. We're not too much concerned with the locked, because we know nobody can undo it. So if I put a tick here, so and if I try to write it, what I'm trying to do here is all these pages from all these log bits from P10 to P15, so these will be locked from any changes. So let's try to write. So I know that, so I have shown here by means of a red checkboxes here. So we know just now we read that in order to activate this new configuration, you have to start a new. So either you can click on activate, or probably now we always look for a safer thing, just lift and try again. So activate and read. Okay, now here if I this is my software is trying to do it, because I know these 5 bits are controlled by the block locking and preventing the user from modifying. Let us go to this unsafe mode. So let's try to try to change this unlock and try to write, and writing is successful, looks like it's successful. When you try to read, look at that. So the write was not done to the tag. So in other words, we are not able to change the content of the log bytes. So we have frozen that to 0, and we could not change that to 1. So that is what the block locking bytes are. And there's also one more thing here, which is the OTP. That will be I'm going to discuss that soon. So you can also lock the OTP, but again it depends on your application. Why would somebody want to lock the OTP? Because OTP is a very nice feature. And likewise, what about this one? Say for example BL 4 to 9. So the 4 to 9 refers to this bit P4, P5, P6, P7, P8, P9. So now there is no difference, because all these bits are already locked. So even if I do this, it's not going to make any difference, because nobody can unlock these pages. So you can just try, and that's gone. And similarly, assume that we don't want, even now if I give this to my customer, anybody can lock the OTP. So if I want to prevent the locking of this OTP, so I can just put a tick here, and this should control or prevent anybody from modifying this. So right, so even the OTP has been is always writable. OTP, you can never ever log this page 3, and because there's nothing else to change here, this software has disabled the write. So if you want to change again, let's try to reactivate. Let us try without removing the card. So clear, so reactivate, and can I, yeah, okay. So yeah, that's all. Next we'll see what's the use of OTP and how the OTP is used. So next we're going to see how the OTP works. OTP stands for one time programmable. Also means once you write something, you cannot undo it. It's also called as the capability container, and which you will come across when you start reading about NDEF. Now this is again like a log bytes. this is also a bit operation where you can change a bit from 1 to 0, and it is irreversible. But it is irreversible only in case of the MIFARE Ultralight tags. But I have made few videos on SRX 4K tag where the OTP in those tags are reversible as well. So that's the good feature to look for. What are the applications of this OTP? There are plenty. So something, the ticketing is one of the ticketing application suits this, because you can have a 7-day ticket or 31-day ticket. Every time the user uses the ticket, you can just set the OTP to 1. So literally it starts from 100. So when somebody attends an event, make it 1, and so on. So each bit represent 1 visit, and it's also a good application for the clocking. When you clock in, somebody like the employee time clocking. So this OTP, this entire thing is also used in NDEF. So I'm going to make videos later on NDEFs. There you're going to see that the capability container, this is the information that describes the size of the tag and what version and so on. Everything is stored in the OTP area, and we're going to see that later. So let's see how the OTP or discuss in detail about OTP. So there is a nice example in the documentation, and as you can see here, the OTP is at page number 3, and this is the default values of the OTP. Again, the all OTP bits here in this Ultralight is 00, all zeros. But if you buy like a NTAG, a 213, or you will see something written here. That's the they come with some kind of a value for the CC, the capability container. So take this example. The first write to page 3 is this bit pattern, and after the write, this is what the OTP will be. So try to write it again, but this time with a different data altogether. But keep in mind here all the bits that are 1. So here in this case the least significant bits are 1s, and I'm trying to write the data with the least bits as 0s. But after the write operation, you can see that the data has not changed. So this is how the OTP works. So once set to it will be 0 when you set it to 1, and you can never go back to 0. So let's see how this is done, the Ultralight tag. So it's again pretty straightforward here, and this is a new or a blank tag with all the OTP bytes as zeros. So I made a nice user interface here again with the checkboxes, and I'm going to write set 1 bit and write, and OTP is set here. Let us try to write remaining 3 bits here. So that's fine. Now if I unlock it, so now with this locked, again this is very similar to what I have done in locks. You cannot modify, the software is preventing you from changes. Let's try to go in unsafe mode, and I'm going to unlock, and I'm going to write 1 here. So this is something I'm introducing now, so maybe I'll set this these 2 bits. So try to write. So it says the write is successful. So we have received 0A here. Try to read. Go back to this the grid and click on the R, and as you can see those 3 bits they came back. That means we are not able to change from 1 to 0, whereas these 2 bits these are new values we are writing, so they just remain there. So that's how it's very simple concept, and I'm just going to this card is no use for me now. So every time you experiment or speak about locks, you'll always end up losing a tag. So let's try to write them all right. Okay. Alright, thanks for watching, and please subscribe to my channel. So more videos are going to come, and see you soon.